may send the data across to us here soon. I don't know. This well that you just looked at was a Pioneer well that they traded for or something, but they're drilling, uh, you know, Barnett Woodford well right now, and they just logged it. So they just put the wire line down the hole, got the logs back, and they're tripping the BHA in right now to go lateral. So he's kind of concerned about targeting. He thinks they may have made a bad choice on landing zone or something based off of the analysis that we gave them. So they're having like an emergency meeting or whatever to discuss it, just to figure out what they're going to do. But anyway. What else is going on? Nobody has anything.
I think 2 passed.
Yeah, so the email that Corey sent out is the one you're talking about, right? Yeah, so I haven't talked to him yet or Ben about it, but I read the email, and so we'll see what that's going to be. But it's hard to describe, right? Like a lot of these things, there's history behind all of it. So Tora, I think it's from the University of Texas, Austin. I'm not sure. But anyways, these academic people embarrassingly come up with this shit, like it's just shit. And I don't know how it happens, because you would think that at a university you've got these professors and stuff, and they're the ones that are teaching the students, so they should be smart, right? But they're not. And they publish lots of papers too, and you think, wow, you publish lots of papers, you should be smart, but they're not. And what they had done here, let's do this. I've seen this a couple times in my life, and it irritates the fuck out of me. This is what I've seen. So I was at Ingrain for a long time when I was with Apache, and hold on a second. How do you zoom in? 1.6%. Whoa. I'm gonna do 15%. What I seen at Ingrain. So if you don't know what Ingrain is, it was a company, but now exists as part of Halliburton. I believe they bought it, where somebody decided to take cores and scan them in a high resolution CT machine. So, you got your core or whatever, and you put it in the machine. Here's a little machine, right? It zaps it with gamma rays. And what you can get from this is the same thing that you can get from a bulk density tool. So you can get bulk density, and you can get PE. And you do that through processing that data. And what the CT scan gives you is tomography, right? So you get like you can look inside the core and get high resolution detail about the density and PE differences inside of the core, right? Lithology and all kinds of, you could see little fossils and shit, all that neat geology stuff that doesn't really matter. But what these idiots did is they put together a facies model. This is how they did it, because they've only got like a couple of things to work with, right? Instead of doing, well, by the way, you also get gamma ray, potassium, thorium, uranium, whatever. Like you get a whole bunch of other things other than just that. But gamma ray and bulk density is pretty much what you're working with. What they did is they built the cross plot of PE and bulk density, and you've got like this data all over it, right? It looks like that. They said, we need to break this into facies to do analysis and things. Joel Walls, who is now with Halliburton, I believe he went over when they sold it. He's got a PhD, right? This is like a PhD geologist. How do you think they designed their facies model on this? This is what they fucking did, right? They said, this is facies 1, that's facies 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8, and that's 9. I'm not joking. This is what they did. Okay. To me, as a practicing professional, right, who carries a license, by the way, I have a license, just like a doctor does, right? If a doctor's a bad doctor and they do bad things, what happens? You get your license taken away, right? And then you're not allowed to practice anymore. You can't work anymore as a doctor. I think the same should be for geologists and petrophysicists. You should have a license. And if somebody catches you doing this, right, they should take your fucking license away, right? You're done. You don't work anymore because this is stupid. Now, fast forward to Tora. What did Tora do? Tora made a cross plot of gamma ray and neutron or something like that. Okay, I think that's what it was, or resistivity, or I don't know. There's two curves, and they did it for the whole Permian Basin. So there's this massive data cloud. And how do you think they did their facies? It's the second time I've seen this stupidity, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. That is Tora. So they've got a consortia or something that Diamondback belongs to as a member. And as part of that, they have access to this model for thousands and thousands of wells, because most of what these guys are doing is garbage at the academic level. They also, like the geologists who know nothing at all about signal processing or mathematics for that matter, because I don't know about Thailand, but I'm starting to wonder if geologists take any math classes at all. But they decided to get into all this deep signal processing math and determine that they were good to go using dynamic time warping for picking tops. Right, so they've got like this automated top. There's all kinds of papers published. That's the one thing about the academics, is you can find out what they did. All you got to do is go on the internet, and go to Google, and you'll pull up all kinds of PDF presentations and everything else that they've put out there. But these methods you know, um, I think they're far out of their domain. Like they don't. It's like a little kid, the way that I see it, right? Like a little kid stumbling into somebody's workshop and just playing with the tools. Like they don't know what they're doing, but they're like, "Oh, cool! Like I got a doodad or a thingamabob." Like, well, do you even know what that's for, Johnny? Like, no, but it's cool, and like they're using a scalpel as a hammer or whatever because that's what they think it's for. So there's been a lot of that happening lately because of the access to AI and computers and things. People who are not subject matter experts are just taking shit that they shouldn't be using for a specific task and using it for that task. And because of that, I think, well, if I read that email carefully, something's happened where I think these guys got enough negative feedback. Here, let me share my screen. They got enough negative feedback that they did something. Okay. So like the original one I told you it looked like a tic-tac-toe. So this presentation, right? This is what they've done now. Like it's like, okay, we've tweaked the polygon domains, using PE color codes. So now it's better. Now it correlates to depositional systems and all this stuff. Come on, right? This is still bad. What you did is you took something really bad and you made it probably worse. I don't even know. So they're using V clay now instead of just gamma ray and whatever it was before. And they're using resistivity. Now, I know it's gamma ray, so it's just V shale from gamma. So it's gamma ray versus resistivity. That's the plot. Based off of all the facies work that you've been playing with, I think you can appreciate why this is not the right approach. So, anyways, I don't know where Corey's going with this, but he says, that they want to try to use this because they have it everywhere, and they want to see potentially if they can, find some other model that ties to these facies better or something. I don't know. He's saying they use gamma ray resistivity to break out facies, but could recreate their cutoffs for all facies using our normalized gamma ray logs and resistivity data, allowing our geologists potentially to have a version of the tora facies on any well with gamma ray resistivity. Right. So he's just saying, like, can we set up like a program or something, a piece of software that can do this for us so that we don't need to rely on them. And of course, that would be incredibly easy, right? Because all we have to do is just figure out what these boundaries are and write some basic logic, right, to separate those domains. So you could just throw this into a digitizing program, right, and get those polygons. That's not a problem. So that's kind of what he's asking, I think, at this point. I don't know where he's going to go with it, but this gives me, as we say in English, right, a lot of heartburn, which means that it's made me throw up, right? Because I mean, I don't know. I'd like to see or understand, like, how they came up with this, because I think if you build any sort of models, right, they claim at some point that this was tied to core analysis somewhere, right? Distilled core facies into wireline facies. I don't know what cores they had access to. I think he says in the emails that there's like 3 cores or something. Where is the other? It's in the email, but it's not in here. It's this thing here, right? The wireline log source and core calibration contains 4,000 wells. And it's got all the correlations and tops picked, right?
Mhm.
Three wells in Martin County. Like, now, you guys sit there and tell me that this is something that you would hang your hat on. You know, it's like saying I've got a petrophysics model for the entire Permian Basin. I've got 4,000 wells I've done petrophysics on, and I've calibrated all 4,000 of these to 3 cores. Right? Who's going to take that seriously? You'd say, well, like, where are those 3 cores? Like, do they have all the different formations? Like, because when you say 3 cores, you know what that means, right? If you've been looking at this
Yeah.
data long enough, like I have, the first thing that you hear when you hear 3 cores is you hear 3 formations, right? Because people don't core everything in a fucking well. They don't just like, yeah, we're gonna core the whole damn Permian section, like 8,000 feet of core. No, they core the Joe Mill. That's it, finished, whole core, right? Because it's expensive. So, and it's also like a difficult thing to do. It's not easy to core. You can have problems. You can get stuck. And anyway, so that they core the Joe Mill. That's 1 core of the 3. Maybe if you're lucky, you get like the Joe Mill and the Middle Sprayberry or something, or the Joe Mill and the Lower Sprayberry. You get an adjacent formation, but you're not going to have everything. So that's 1 core. Second core is probably Wolf Camp. You look at the Wolf Camp all day long now. The Wolf Camp is thousands of feet thick. Where did that core come from? They didn't core the whole Wolf Camp, probably. Then you've got the Clear Fork. You've got the Dean. You've got the Strawn, you've got the Woodford Barnett, you've got Devonian, Grayburg, St. Andreas. You got 3 cores. You got 3 formations that you've tied this all to. So, and I think this is kind of, how do I make this bigger? This was the original one, I think. Yeah. So they had 9. That's how they did it. It's not quite as bad as the tic-tac-toe, I guess, but that's what they did. And then now that's turned into, they added 5 more, because how do you make something better? You add more to it, right? Like if you've got something that's nice and it works right, like a car, right? What do people do to make it better? They go and buy all this garbage from Mr. DIY and they start gluing it to it. They got a fin on the back, right? They got glowing lights underneath it and speakers and booty bum. You got everything on that car, right? And then all of a sudden now it's faster because it looks cooler because it got stickers on it. They chopped the muffler off, right? And that's kind of what I see here. I don't know. I'm just like a grumpy old man, but that's he called me again. Oh, he said, sorry, butt dial. Just got off the phone with him. Anyway, Eric is like, he's panicking today. Yeah, fuck. We targeted the wrong zone.
Oh,
But anyways, too, you asked about faces. There you go. So that's the thing that Corey's asking for, I think, is that he wants to have a program or a script, and it may be something that we need to do inside of a program like Petra or Kingdom. So, Python's always an option, I think. But you can go to, I think if you go to automaris.io website, there's a free digitizer or you can upload a picture and then just click on the screen, you scale the axis or whatever, tell it that it's logarithmic, and you can figure that out. The only problem with this is it's V shale gamma ray, and we don't know how they calculated that. Or this up, yeah. So like we need to figure that out, I guess. Look at these maps. Like, how could you even stand behind any of this either, Like, these are people with PhDs, smarter than us, right? Like, oh, he's a doctor. He must be smart. This is University of Texas, or BEG. Is it the BEG? Maybe that's what it is. I'm still looking for the. They don't. I think Corey made this email, but if you look at, there you go, Bureau of Economic Geology. So, okay, fair enough, right? Maybe I jumped the gun on this, but I think it's part of University of Texas. But typically the BEG, like if you're smart enough to get a job as a geologist, you go work for a company, and you get paid money because you work for a company. You're doing real work. Like if you're not smart enough to get a real job as a geologist, you go work for the BEG. And it's like government work, So low salary and like low performing individuals. So anyways, not that I mean to shit all over these people, but come on, guys, right? Come on. What is this? Wolf Camp A mode. Like I feel like I've taken some drugs here. You look at their own thing here, it's like it doesn't even make any sense. These guys, they're trying to work these big scale projects, but they don't understand the problems with it, right? That we suffer with every day. Back to this sort of thing, working with this crap yet. I've got all these wells in here. How do you even do something as simple? We're not even talking about facies. We're just talking about trying to convert a gamma ray neutron to a neutron. How do you do that over all of these wells? And then that's only a postage stamp compared to this whole thing. It's like ridiculous how many. This already is 1,500 wells. 1,500 wells, and it's just this little tiny thing. If you count all of these, there's 1,500 in there. And that's the whole Permian Basin looks like this 20-acre spacing, 10 just well after well after well. The whole thing is drilled. So, you got to worry about normalization. You've got to worry. I mean, especially on this sort of scale, because if you log every one of these, I was part of a project that did this early in my career. We drilled 580 wells in Deadwood. We had 52 rigs running, vertical wells. I had like 15 of those rigs were mine. And we would just TD well after well, boom, 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 boom. And these things were all the way from the Grayberg to the Devonian, Fusselman. Because we were drilling Fusselman targets out there. So like each well was 4,500 or 5,000 feet to 12,000 feet. Every well, 7,000 foot of log to interpret. And I'd get like 7 of these wells a week, one every day. Right? TDOL, boom, new logs. And every single well was logged with quad combo. Sonic, neutron density, PE, resistivity. Sometimes, and every single well had spectral gamma ray. Every single one. 580. And they were this close together. And we had every logging vendor logging. We had Weatherford, Halliburton, Schlumberger, or Slub, like a couple other wireline companies out there too. And I kept seeing differences in the data every day. I'd get a well, comes in, boom, right there. I get another one next to it, and the PE is different, or the gamma ray is different, or the resistivity is different. Same fucking rig, same drill pipe, same bit probably, right? Only a little bit away in distance. Same geology, same formation, everything's the same. The only thing that's different is the petrophysical log data. So the question is, how do you deal with that when every single one of your wells is different? That's the world that we live in, right? The measurements that we make change. They change because of the temperature, because of the, the humidity in the air. Like, I don't know. Different engineer, different acquisition software, different tools, different wellbore, different mud, different logs. Same rock. And you've got to deal with that somehow. Now, what happens when you've got all that going on and you do nothing to correct any of it and you dump it into a facies model like this? So think about it, right? I'm in facies 14 in one well right next to me has a different gamma ray that needs to be normalized, but wasn't. Now I'm in facies 10, right? Like these three facies they're going to blur with each other unless you get your gamma ray right. Resistivity, right? Look at where we're at here. This is 2 ohm meters to 200 ohm meters. What happens, when you've got induction versus lateral log resistivity?
Oh, right.
And some of these things, like how much can that push you? Especially on the high end, like how much can that change that? Scares me a bit, like maybe, and on the low end too, lateral log versus induction can be quite different. So, this facies 7, I think, is the one that would suffer from the resistivity tool differences. It would flip and flop. But they only do have like one line basically on resistivity. So it's like right at 20 ohm meters, which, go pull open your petrophysics, look at a well anywhere, and what you're going to find is that there's a lot of things that are 20 ohm meter, right? Here, and and we know that because look at the shading that we use in our plots, right? Everything that's black is greater than 20 ohm meter. Look at where a lot of this data rides. It's like it's all kind of flipping back and forth on 20 ohm meter, right? So, anyways, whatever. BEG. So if you want, you can try playing with this to see if you can figure out a way to digitize it and break it into the facies that they have. But in order for us to proceed with that, we need to figure out how this is being calculated here at the bottom.
For the Mustang well, I reviewed the slide that Jorge sent me latest. I made a new spreadsheet, and so in database we only have 20 wells from 36 wells. So I will update him.
Okay, so yeah, what we need to do, what I need to do, right, I'll do that here soon, is extract the wells we do have from so that we got 23 or 21 wells, right?
Right, 21, but we have.
Yeah, I'll I'll extract them into a database
Okay.
so you can start looking at them.
Yeah. So hot today.
There, I just sent an email to Corey. Well, we'll see what he says back. But like what you can do with these two, which I'm sure you're well aware too, is you just because all these lines are straight lines, even though they have segments in them, right? You can do a 2-point fit on it. So you just digitize it, you get the endpoints of the line, and you make an equation for a line, right? And then you get all the different line equations, and you're just going to have to, like, it's a little bit complicated mathematically, right? From the algebra and everything, but you'll have a whole series of line segment equations that you need to then figure out where the data is, based off of the equation. So, it's like if you got the equation for line 1 and you have a data point, and you know that you don't know where the data point is. Is it on the left of the line or the right of the line? You can figure that out by using the line equation and then inputting the value that you have for the point. It's like if you got an X value for the point, you put that in the equation, and it'll tell you where the Y value is for the line. And then you could do the same thing for all the segments or whatever to figure out where you are. If you're in region 1, 2, 3, 4, 5, like that's one way without Python, just using very simple logic statements. You could put something together that could be usable in Petra, because Petra, if you've never used it, it's like a really basic old shitty geology program for mapping. Like it doesn't have, although I say that, and it may have Python function. Let me ask Calvin real quick. Oh, if Petra and Kingdom have Python. Because that's sort of the game changer. If we can use Python, then you can do whatever you want, and it'll run in there. We just need to know what the API is or whatever, but to get access to the gamma ray curve or the resistivity curve. But if we're stuck, just like an IP, you got to use user formulas, multi-line formula. Like that's the kind of world that we would be living in. I'm pretty sure we have to work around that. It's easy for us to write an IP program, but the geologists can't use that on their hundreds of thousands of wells that they have. That for some reason we need tora facies for. I don't know why. What else we got going on? Nothing?
Nothing.
Well, I'll get you that database here soon, just so you can start playing with that Jorge thing. But in the interim, have a look at that public database too. If you don't have anything going on, start to clean that thing up, so we have something to work with for publishing. The other thing I'm trying to do is I zipped up all of the Core Lab tight oil consortia data. You're talking about that, right? It's 138 gigabytes.
Oh, too
Yeah.
much.
So I can't just download it, especially on the hotel Wi-Fi. So I'm gonna have to go back through a second time and get rid of all the junk, because there's like no reason for it to be that big, right? It's most likely that there's lots of core photos, high resolution ones, and D-list files and shit like that we need to get rid of. I just kind of keep it to the tabular data, spreadsheets and last files and things. So I'll need to scrape that. I'm sure that we can get it down below a gigabyte, right? Like that's just a lot of stuff we don't need. So once we get that, then we'll need to, did I already do that? Did I create a database for the core facies stuff or not? Okay. Yeah, so we'll need to, at some point, we've got a lot of those wells in IP already in the master database. So we just need to extract them, and whichever ones we're missing logs for, we have the logs. So, we can load that up and then load all the core data in. Because like I say, where I see that being ultimately the most value to Diamondback is not just having, lithofacies that are tied to the core descriptions, which are better than Tora. And now we know why. But it's to tie the core data itself to something. Like at the moment, the other problem that we have is the way that core data enters the system is different from logs. Like for logs, we have mnemonics, right? Gamma ray is GR. You've got to edit GR, you've got a final GR. You can find gamma ray, and when you find it, you know what it is. It's a normal, total gamma ray. But for core, it's a lot trickier, right? Like when you say, oh, I've got permeability data. Okay, let's talk, right? Sit down, grab a cup of coffee, because what kind of permeability data? How was it measured? Right? How was the samples, or how were the samples prepared? What kind of confining pressure was used? Were they extracted or unextracted? Right? Were they dried in an oven or not? Was the permeability measurement made with pressure decay? Was it made with fluids in a core holder? If so, what kind of pressure was used upstream and downstream? What kind of fluids were used? What was the relative permeability, or the instantaneous relative permeability and the saturations of the phases during the core flood measurement? What was gas involved or not? How many phases of fluids, right? Was it an absolute permeability to gas? Was it an absolute permeability to water? Was it an absolute permeability to oil? And so, I can just keep asking these questions all day long. And what you find is that every single measurement, if any of these parameters change, it's a different permeability measurement. The numbers are not comparable, right? So when you do analytics, you want to compare. You want to compare permeability to permeability. You don't want to compare a liquid perm at room temperature with no confining pressure to a gas perm at reservoir temperature with confining pressure. You know, you don't want to compare a permeability, a two-phase permeability, steady state to an unsteady state permeability measurement, and so forth, you know. So there's just lots of things that go into all of this. And the tight oil consortia data, once we get it, we'll be able to have control over a data set that we can create. And what's going to make it the game changer versus doing this by hand 5 years ago and before is the AI, right? So now we've got something we never had before that we can dump all of the data in and tell it, here's our problem. You know, we need specific mnemonics. We need, you know, to load this data so that when we go to compare it, we're comparing apples to apples. So GRI perm, right? Like GRI is a bad thing because the permeability measurement is sort of shitty, but it's a good thing because GRI it's a procedure, right? It's from the Gas Research Institute. It was developed actually by a friend of mine and my mentor, Matt Maver, who had a research grant to develop a lot of those laboratory experiments, and they were developed in the 80s to the government paid people to do research on coal bed methane. And that's where GRI came from. So, you know, for coal bed methane reservoirs, if they want to measure permeability and stuff like that of the matrix, you know, coal, tiny pores, right? And that's kind of like where all the whole shale thing looked to, because there was that huge body of research that was already done. So there's actually a document. I don't know if I've ever given it to you guys. I think I did at one point. It's like 500-page book or something that details all of this stuff. Like how does GRI work? How do you crush the core? You know, when you do the sample measurements, because you could just say crush the core. Well, that doesn't work. You know, like if I crush it into really big pieces and then try to measure the permeability with a permeameter, a pictometer, right? Gas permeameter, or I crush it into dust, right? And I try to measure it. Totally different measurements you're going to get. So there's standards for sieve size. There's standards for sample preparation. How is it cleaned, right? What kind of fluids are used? Do you use sock slit extraction or not? Do you dry the samples in an oven or not? How long do you leave the samples in a extraction, right? Et cetera, et cetera. Like it all impacts how that permeability is going to come out. And the pressure decay perm is basically mercury injection experiment, right? You're doing, but instead of using mercury, you're using helium. So like you're looking at the pressure decay, you know, and it's like in theory, everything sort of lines up, but as you know, you could have a core that's got very high permeability because of texture, right? The fabric and texture of the rock, you've got little natural fractures in there. You've got all these little pore throats that have some sort of depositional influence on them, and they flow fluid really well just because that's the texture of the rock. Well, then you take a fucking ball mill and you smash it up and turn it into little rubble. And now the permeability set, you know, from the gas permeameter says like, well, this is like really tight stuff, low permeability. Well, why? Because what made it highly permeable, you destroyed by crushing it. So GRI perm can be bad, right? Because it's not representative of the reservoir because you destroyed the reservoir by crushing it. So anyways, lots of work to do there, I think, on turning this core lab tight oil consortia data set into something meaningful that can be used for correlation and analytics. So that, once you get your facies set up, then all of a sudden you can tie permeability to facies or something. You could tie, all these different models, these petrophysical models that we have. We can improve those through the core measurements as a whole data set. Like I think there's, I don't know, 120 wells or something in this core lab consortia data set. So it's a great opportunity to be able to do a little project and say, look, I can help refine your petrophysics. We can improve our MN calculations. We can improve a lot of things. But before any of that can happen, we've got to get the data loaded properly. Like some measurements, M and N, Archie's electrical parameters, there's not really a million different ways to do those. So, we should be able to compare well to well, but permeability scares me. And again, it makes me kind of like sick to my stomach when I hear people talk all the time when they just say, yeah, the porosity in the perm is this. And I just think to myself, like, you're characterizing an entire reservoir with a single set of numbers, like the porosity is 8%. Like the whole fucking thing is 8%, really. And the permeability is 5 millidarcies. Like, that doesn't even make sense to me anymore when someone says that. Like, if you say that, you don't tell me explicitly what that means, I don't understand it. 5 millidarcies. 5 millidarcies to what? Under what conditions? Like, what is it, 5 millidar? It doesn't even make sense when you say that. The permeability of the reservoir is 5 millidar. To what? To water, to oil, to a mixture of water and oil, to gas? Under what pressure can, the permeability, all of it doesn't make sense. You got to be specific, The permeability is 5 millidarcies to single phase of fluid when the relative permeability or the saturation of the different phases in reservoir are X and Y under this temperature, this confining pressure, this reservoir pressure, okay, that's what the permeability is. The geologists are quiet. They're like, oh, we just thought perm was just one number. Really quiet. PMP, it's your namesake.
Oh. PMP.
All right. Let me let you go here and make a coffee, and then I'll send you a note when I get this database of Jorge's stuff
Okay.
pulled out. All right.